How is the speed of a moving object calculated? Case 1. Same distance, different time. In a running race, 3 players were supposed to cover the same distance, which is 1 kilometer, to reach the finishing line. The time needed by each one to cover this distance is shown in the table below. To cover this 1 kilometer, the first player needed 33 minutes and 26 seconds. The second one needed 33 minutes and 10 seconds. The third one needed 33 minutes and 40 seconds. Compare the time needed by each player to cover the same distance. Compare the time needed by each player to cover the distance. The time needed by the second player to cover the 1 kilometer is 33 minutes and 10 seconds, less than that of the first player, which is 33 minutes and 20 seconds, which is less than that of the third player, 33 minutes and 40 seconds. Now determine the player who was the first one to reach the end line. So the second player was the first one. Why? Because he needed the least time to cover the same distance. So he reached there faster. So the second player was the first one to reach the end line because he needed the least time to cover the same distance among the 3 players. Now compare the speed of the 3 players without using values. So we said that based on the answers of parts 1 and 2, compare the speed of the 3 players. The speed of the second player is the greatest among the 3 players, while that of the third player is the least among the 3. So needing less time means moving faster. Needing more time means moving slower. Deduce the relation between the speed and the time for the same distance. So for the same distance, as the speed increases, the time needed decreases, or the duration decreases. So the formula to calculate the average speed is V speed over equals to D over delta T, where delta T means duration. Now doing a cross multiplication, we can find, if you are given V and T, we can find D by saying D equal V times delta T. For the same distance, as the speed increases, the duration decreases. So if 2 objects are to cover the same distance, if one moves faster than the other, then it needs less time. Does the given formula agree with the deduction in part 4? Yes, it does. So this is a mathematical prerequisite that agrees or that confirms the following formula. When the product of 2 parameters A and B is constant, the 2 parameters are said to be inversely proportional. So here we have D equal V times delta T. D is the constant, it was the distance, the same distance. And A and B are V and delta T, so they are varying. As one increases, the other decreases. Now case 2, same time, different distance. Consider an airplane and a train that departure from Paris to Lyon at the same instant. The duration of the trip from Paris to Lyon by an airplane is 1 hour and 5 minutes, while the duration of the trip from Paris to Lyon by train is 2 hours and 4 minutes. So as you can see on the map here, using the airplane, it needs 1 hour and 5 minutes to cover this distance. However, it needs 2 hours and 4 minutes to cover the same distance, almost the same distance by the train. So it needs more time. Okay. Now at the time the airplane reaches Lyon, after it reaches the destination here, after departure from Paris, the train is halfway between Paris and Lyon. So by the time the airplane reaches the destination, the train is just halfway before reaching the destination. So it only covered half the distance. Given that the distance between Paris and Lyon is 463 kilometers. So fill in the table below based on the given information. Means of transportation, we have the airplane and the train, and we have to compare the duration and the distance. Okay, so during 1 hour and 5 minutes, the distance covered by the airplane is the whole distance, 463 kilometers. However, that covered by the train during this same time is only half the distance, almost 231.5 kilometers. So same time, lower speed, less distance. Compare the distance covered by the airplane and the train during the same time. During the same time, the distance covered by the airplane is 463 kilometers, greater than that covered by the train, which is approximately 231.5 kilometers. So whenever you are asked to compare, you have to mention values and use comparative adjectives. Part 3, without using values, compare the speed of an airplane to that of a train. The speed of an airplane is greater than that of a train. This is logical because if during the same time more distance is covered, this means that it was moving faster. So now deduce the relation between the speed and the distance for the same time. For the same time, as the speed increases, the distance increases. And this is true for the airplane. Now concerning the formula V equal d over delta t, we can say, working it out, we can say that V is like V over 1. So d over V is equal to delta t over 1. So it's delta t equal d over V. For the same duration, as the speed increases, the covered distance increases. And does this given formula agree with the deduction in part 4? Let's check it. Yes, it does. So what is the mathematical prerequisite that agrees with our conclusion? In mathematics, we know that if two parameters E and F are divided by each other and the ratio is constant, even if E and F take different values, so if it's constant, then the two parameters are said to be directly proportional. And this is true for our case because we have that the ratio d over v is equal to constant. So for during the same time as the speed increases, the distance increases. Application on the formula. Or before that, let's define each term in the formula. The speed, its symbol is v because the speed is the magnitude of velocity. We are going to talk about it by the end of the lesson. So that's why its symbol is v, not s, because it's the magnitude of velocity. Its SI unit is meter per second, ampere s. Distance is, its symbol is d, and unit SI unit meter, m. Duration delta t. Why delta? To show that it's the difference between two instants, like t final minus t initial. This is expressed at delta t. It is the interval time between two instants. SI unit second and symbol s. Application 1. Calculate the average speed of a car that covers a distance of 40 meters during 2 seconds. V equal d over delta t, 40 meter over 2 seconds, given both in the SI unit, so it's 20 meter per second. Suppose that the car moves at constant speed. Calculate the time needed by the car to travel the distance, a distance of 65 meters. So delta t is equal to d over v. It's 65 meters over 20 meters per second obtained in part 1, so it's 3.25 seconds. This is a further explanation for the formula that I discussed before. So having the original formula as v equals d over delta t, it's like I have a over b equals c over d. I can express it, I can do a cross multiplication, so I obtain d times 1 is v average times delta t. This is another formula that I can use if I want to find d given v and delta t. Here I use this one if I'm given d and delta t and I want to find v. And finally, if I am given d and v and want to calculate delta t, I can use make use of this rule, which says that c over a is d over v, and thus I get that delta t over 1 or delta t is d over v, and I obtain the following formula here.